I'm at the Paleozoological Museum of China, or the Paleontological Museum. My first video we went through the history of humans. They have a smaller gallery that deals with Peking man, and it goes all the way back to Australopithecus. Talks about some of the morphology similarities between proto-Homo species. So we were talking about our fish ancestors here, and we just went through the ray fin fish and cartilaginous fishes. So now we're going to do actinopterygians, the most diversified group of fish. Bony fish, osteichthyes, are divided into two major groups: ray-finned actinopterygians and lobe-finned sarcopterygians fishes. The ray-finned fish have fins consisting of flexible fin rays. Lobe-finned fish, fleshy fins or limbs well supplied with muscles. The ray-finned fishes include the Cladistia, chondrosteae, neopterygiae, including the teleosteae and their fossil relatives. They span from late Silurian to present, being the most diversified vertebrate group today with about 29,000 living species. So here's a cladogram of their relationship. The phylogenetic tree of the ray-finned fishes. Giant fish killers cruising Triassic. Neopterygians, including primitive neopterygians, holocene and telestine fishes. Primitive neopterygian and the earliest flying fish. Potaichthyes. Sipanceriform sturgeons and their relatives. I saw the giant Chinese sturgeon 2 days ago at the aquarium. That and the beluga whales were the highlight. Triassic ichthyosaur-like fishes. Extinct primitive ray-finned fishes. Watch my video of the belugas singing. The most primitive living ray-finned fish. Looks like an arowana or something. Lobe-finned fish. Schizotheracine fishes, snow carps, became adapted to the changing habitats caused by rising of the plateau. The higher elevation, the fewer carp scales, barbels, and pharyngeal teeth rose. Talking about the rise of the Tibetan plateau as the Indian subcontinent crashes into Asia. There's a snake species too that survives in the high area there by going into hot springs to catch fish. It's pretty neat. It's the highest living snake. Holocene fishes include two groups: Heliocomorphi, bowfins and their fossil relatives as old as the dinosaurs, and Ginglimodi, gars and their fossil relatives. Most common bony fishes today, for example, carps and perches, are teleosts. I've been reading the fossils, fine print. That is. They have some new finds here. This one's from 2008. Silurian osteichthyans, extremely rare, often scattered. Guiyu, so far, world's oldest articulated fossil osteichthyan. Yunnan province, huh? A coelacanth fish from Africa and a living fossil. Latimeria is a recent coelacanth with paired lobe fins. It shows a character transition from fish to four-limbed vertebrates, and thus sometimes it is also called a four-legged fish. The genus Latimeria now includes 2 species. L. calumni, West Indian Ocean coelacanth. L. manataensis, the Indonesian coelacanth. This specimen, 1.65 meters in length, 65 kilograms in weight, caught April 5th, 1976, given to the IVPP as a gift from the Comoronian government, March in 1981. The discovery of the Latimeria in December 1938 was one of the most dramatic scientific events in the 20th century. Shortly after the first Latimeria was brought out of the water, scientists found that it was almost identical to the fossil coelacanths, whose ancestors lived 400 million years ago, making it a classic example of the living fossil. 2 species of Latimeria both live in deep water along coastlines, one in the West Indian Ocean and the other off Indonesia. Hunting for fishes and squids, it has been reported that they can slow their metabolic rate to reduce their food requirement. They have a lifespan of 100 years, up to 100 years, at both individual and phylogenetic level. Latimeria is truly long-lived, so long live Latimeria. They might have had one of these when I was in Bangkok at the Chulalongkorn Museum. They have a natural museum, natural history model of Latimeria embryo showing oviparous mode of reproduction. Egg-laying. Sarcopterygians, our fish ancestor. Sarcopterygi, lobe-fin fish and tetrapods, is a group of osteichthyes forming the sister group with actinopterygi. It differs from other fishes in fleshy lobe-paired fins. The monobasal articulation of the paired fins evolved into 4 limbs in land vertebrates. The Sarcopterygians first appeared in the late Silurian and were diversified during the Devonian, when they became more abundant and varied than the Actinopterygians. Most of them became extinct during the mass extinction event at the end of the Devonian period. Living Sarcopterygians include 3 groups: coelacanth, lungfishes, and tetrapods, to which we belong. Nowadays, most scientists agree that the tetrapods are more closely related to lungfishes than to coelacanths. A Devonian 8-digit tetrapod. Euporosteus unionensis, one of the oldest coelacanths. Saurolepsis, one of the most primitive Sarcopterygians. Youngolepsis was the first Chinese fossil fish to be well studied with continuous sectioning method. Professor Minan Chang from the Chinese Academy of Sciences discovered that this fish had no internal nares, ruling out its close affinity with tetrapods. Let's see, tetrapodomorpha include finned tetrapodomorphs and 4-limbed tetrapods. Canichthyes campbelli, Shang and Zhou. 1993 and 395-million-year-old fossil tetrapod fish from China provides direct evidence for origin of the koana and establishes its homology. It is indeed a displaced posterior external nostril that, during a brief transitional stage, evidenced in Canichthyes, separated the maxilla from the premaxilla. Lungfish. Modern lungfish comprise 4 species in Africa and 1 in South America and 1 in Australia. They breathe with lungs and are hence named. The African and South American lungfishes have paired whisker-shaped fins, and the Australian lungfishes have paired paddle-like fins. Oncodontiformes. The Onchiodonts were an extinct Sarcopterygian group that lived in the Devonian, forming sister group coelacanths to the coelacanths. They are characterized by a highly kinetic skull and pair of retractable, laterally compressed tooth whorls. The Onchiodonts were a mysterious Sarcopterygian group with only 6 known genera. The oldest Onchiodonts were from Phrygian, early Devonian, about 410 million years ago. Saurolepsis lived 416 to 423 million years ago. This early bony fish provides a morphological link between osteichthyans and non-osteichthyan groups. It offers new insight into the origin and early evolution of the osteichthyans. Transition to land, major events in vertebrate evolution. Success favors the prepared mind. This dictum appropriately characterized some of the Devonian lobe fishes for their skulls, teeth, paired fins, and vertebrae bear striking similarities to those of tetrapods, which pre-adapted them for the invasion of land step by step, thus having finished a great leap forward in vertebrate evolution. Vertebrates had to spend 170 million years within the confines of water after the first appearance. Until 360 million years ago, a group of adventurous fish finally made their way on land, beginning a new life there, and started to become known as amphibians. The first land vertebrates were early tetrapods, also known as amphibians in a broad sense, which were represented by ichthyostega. Their emergence finally led to these vertebrates' independence of aquatic environments, and hence their ultimate conquer of land, therefore having greatly expanded the territory of vertebrates. Early tetrapods and amphibians. Tetrapods are vertebrates with 4 limbs. The earliest tetrapods appear in the late Devonian, more than 360 million years ago. Ichthyostega from Greenland is the most famous representative of early tetrapods, and thus is the namesake of the group, known as ichthyostegalids. 3 advanced groups, often referred to as amphibians in a broad sense, evolved from early tetrapods: Temnospondyles, Leptospondyles, reptiliomorphs. One clade of the Temnospondyles developed into modern amphibians, frogs, salamanders, with slippery body but no scale covering, thus called lysamphibians. Lysamphibians, which are also amphibians in a strict sense. From the reptiliomorphs originated the amniotic tetrapods, including turtle, lizard, dinosaur, bird, human, and other well-known tetrapods. Unonsuchus. Letoceps. What is that? Letoepsy. Ariops, an early Permian semi-aquatic temnospondyle from USA. Look at that. Big O salamander. Look at that guy. Looks like a giant salamander. Chinese giant salamander. The baby fish they call the giant salamander in Chinese. Liao batrachus, a Cretaceous primitive animal. Carorus, a Jurassic primitive caudate. Skeletal reconstruction of a mastodontosaurid. Skeletal reconstruction of Oramuchia. Skeletal reconstruction of Microbractus. And that big one. (3D reconstruction of Ichthyostega skeleton. Behind you is a T-Rex skeleton model, 2 IV, PP, as a gift by Royal Tyrrell Museum of Paleontology, Canada. Looks like a gar. You want this? Come and eat it. Eat the food. What do we got here? Little fishy. Little fishy. Rock slate with 100 Lycopterafish on it. Lufengosaurus hueni, Latimeria, Calumni, Tyrannosaurus rex Osborne, Microraptor Gui, Shu, et al. These are important publications, huh? Or this is what they found. Yellow River elephant, Stegodon Sedansky. Highlights of the museum. Let's see. Bird lineage, huh? Bird fossils. Birds, about 40 species of birds have been recognized from the G-hole biota, including primitive basal avians, uniquely skeletal structured opposite birds, and advanced birds. Most of them show adaptations to arboreal life, but there were also terrestrial types. Different food types were also suggested or evidence, such as insects, fishes, seeds, and plants as diet. This is the Confuciusomus. Microraptor, four-winged dinosaur. Feathered dinosaurs. With the discovery of the world's first feathered dinosaur, Sinosauropteryx, in 1996 from the G-hole biota, and subsequent findings of over 10 other feathered species, including four-winged types, the hypothesis of theropod origin of birds has gained a wide acceptance. On March 15, 2013, Professor Xing Xu from IVPP and his colleagues reported the discovery of leg feathers in several Cretaceous basal birds, Sapiornis, Confuciusornis, Cathaornis, and Yanornis, and they called them the four-winged birds, primitive birds with four wings. Oh yeah, they got little wings on their legs, don't they? Much like four-winged dinosaurs, for example, Microraptor, that are also from the G-hole biota, they also demonstrated a distal to proximal reduction pattern for leg feathers in bird evolution, helping us better understand the evolution of avian flight. They look like chickens with those big feathers on their feet. I've seen chickens that have those big feathers on their legs. They look like those Mustang colts, the big hairy hooves. The ones that pull the Budweiser wagon. About 40 species of dinosaurs have been found from G-hole biota, from Psittacosaurus, having the widest distribution extended to Mongolia and Siberia. Large sauropods and ornithopods were also present, but most G-hole dinosaur species belong to the theropods. Pterosaurs. More than 15 species of pterosaurs have been found in the Jehol biota, ranging from the primitive frog-mouthed insect eaters to the advanced terrible fish hunters. Exciting discoveries also include the world's first pterosaur egg with embryo in it, the smallest Cretaceous pterosaur living in trees, and the largest pterosaur of the biota with one tooth, 81 millimeters long, a world record, and estimated wingspan of 5 meters. Nemicalopterus, the smallest arboreous pterosaur in the Cretaceous world. Little pterosaur. This one's off view. So this is the model of the Psittacosaurus. Strata of the Jehol biota. I took a big cross-section chunk of it here. The stratigraphic section was collected 2005 from one of the famous fossil localities of the Jehol biota in western Liaoning province. It originally weighed 7 tons and was cut down to fit in our museum. The typical lake deposit was formed 120 million years ago, with gray and black layers being rich in fossils and yellowish layers comprising volcanic ashes, which shows frequent volcanic activity that wiped out the biota and led to well-preserved fossils. When volcanoes erupt, they bury the fossils very quickly. Usually, when it's an ash eruption, a pyroclastic one, where you get a cloud of ash, that's great, because instead of it being destroyed in hot lava flow, which usually don't get very far anyway, the cloud can cover a large area and cover with an immense amount of ash very quickly, so you get the well-preserved and articulated skeletons, and they're really good to dig through because the rock usually makes a pretty good contrast with what you're looking for in the bone. So it's essentially like if you wanted to cover somebody up by burying them in the sand and then left them there for thousands of years, they'd be pretty well preserved, just dump some sand all over them. Not like they got picked apart by wolves or something, for lying out for a couple months before they're buried. About 500 insect and 60 plant species have been recognized in the Jehol biota. The insect communities include the forest, aquatic, soil, and alpine types with different feeding habits, herbivores, carnivores, parasites, etc. The world's first flowering plant was recognized from the flora, as well as the evidence for coevolution between insects and plants. I think there's an American school group here, or like the international school. It must be. Ekron Draco Avatar. Ekron. So they obviously have an English language school somewhere not too far. Three ecomorphic types have been recognized among these 7 known Jehol choricidaries: a long-snouted type, a short-snouted type, and a highly aquatic long-necked type. Lizards are relatively fewer, 5 species, but also diversified from a robust terrestrial lizard up to 40 centimeters long to a flying lizard with long ribs. Hyphalosaurus linguanensis. Ordo Socheles Liaotiensis. Liao Batrachus. Reconstruction of the Jihal biota. Ooh. A lot going on here. Large aquatic animals, turtles, amphibians, crayfish, wading birds, flying birds, and four-winged birds. Dinosaurs, shrew-like mammals, two-winged birds, more dinosaurs, Archaeopteryx-like bird, feathered dinosaurs, large shrew-like animals, mammals. More than 15 species of mammals have been reported from the Jihal biota, comprising tricynodonts, multituberculates, symmetrodonts, metatherians, and eutherians. There were mouse-sized arboreal hermits as well as 1-meter-long giants by standard of Mesozoic mammals that even ate dinosaur babies. Repenamamus giganticus. Large mammal that lived in the dinosaur world. Liaocinodon is a eutrichodont. Its type specimen, complete skeletal, preserving every single bone from the nostril to the tip of the tail except a couple of vertebrae. Unlike most mammal species, specimens from the Jihal biota that were preserved as part and counterpart, the skeleton is preserved in one slab of rock, carefully prepared by a senior technician from IVPP. I guess by part and counterpart they mean instead of just having an impression, like the mirror image, you know. Let's see. Fish with only about 14 species. Fishes represent major Mesozoic fish groups including Agnatha, Chondrichthyes, Chondrostii, Holostii, Teleostii, such as the world's earliest freshwater lamprey, the ancient relative of Chinese sturgeon, and the Chinese ancestor of American bowfins. I guess we go upstairs now. Get a better look at these dinosaurs from up top. Toilets in the east hall on the ground floor. I'm gonna lay down. Hello. Dichnodont. Panorama fossil locality. Middle Permian, Dashing Shan. Reconstruction of terrestrial fauna from the Triassic. Synapses. The ancestors of mammals. Synapsids are one of the three major clades of amniotes. They derive their name from having a temporal opening beneath the Pastor beetle and the squamoside have differentiated teeth, gradually evolved more mammalian characteristics in the lower jaw, secondary palate, skin, etc., and finally gave rise to mammals. Thus, the non-mammalian synapsids are also called the mammal-like reptiles. Synapsids first appeared in North America in the late Carboniferous, diversified into the Permian, and became the most abundant and largest tetrapods during that time. Hit severely by the end Permian mass extinction, only a few groups extended in Triassic. After the Triassic, only the Cynodontians and their descendant mammals survived. Synapsids include primitive pelycosaurs and the advanced therapsids, and later include Biamosuchians, Dinocephalians, Anomodontians, Gorgonopsipians, Therocephalians, and Cynodontians that evolved to mammal late Triassic. Middle ear structure, Synapida. Dicynodonts, plant eaters, primarily consume in the ecosystem, playing same roles ungulates in African savanna. They were most abundant land vertebrates, middle Permian to Triassic. Their size was generally small in the Permian but increased in the Triassic. Lystrosaurus and Cyanocanaria was named for postcranial materials by blah blah blah. Distribution of Lystrosaurus, early Triassic. Paleographic map. Lystrosaurus. Genus late Permian, early Triassic, Dicynodont therapsids, heavily built skull. Lived in what are now South Africa, Antarctica, India, China, Russia, around 250 million years ago. Lystrosaurus. Mammal-like reptile. Thalattosaurs. Medium-sized marine reptiles with limbs not paddle-shaped and upper temporal fenestra reduced or enclosed, while the lower temporal fenestra semi-opened. Placodonts, armored marine reptile, specialized expanded teeth. Sauroturgians, long neck marine reptiles with single upper temporal fenestra, forelimb paddle-shaped, in derived groups more than 10 meters long. Reconstruction of Sauroturgians. Ichthyosaurs, fish-like reptiles with single upper temporal fenestra, and the forelimbs are paddle-shaped. Reconstruction of ichthyosaurs. Mixosaurus panchiamensis. Ichthyosaurs, fish-like reptiles, single upper temporal fenestra, and forelimbs are paddle-shaped. I've seen ichthyosaurs in a lot of the museums of dinosaurs. They're not all that uncommon. Lariosaurus shinyanensis. Mesozoic sea monsters, marine reptiles. Reconstruction of Triassic marine reptiles from China. As modern sea turtles and sea snakes, many Mesozoic reptiles lived in oceans and even lost the ability of moving on land. With generally huge size and odd appearance, they were called sea monsters by early naturalists. Mesozoic marine reptiles are quite diversified, with major groups such as ichthyosaurs, sauropterygians, placodonts, and thalattosaurs, as well as other clades such as turtles, Hupeksuchians, protosaurians, and archosaurians. In Triassic southwestern China was covered by sea, in which many marine reptiles lived and proliferated. With strong crustal movements, these prehistoric monsters became extinct, preserved as exquisite fossils and buried in nowadays mountainous regions. They are the best example of huge changes between the land and the sea. China has the richest fossils of Triassic marine reptiles, mainly discovered from South China and Tibet. Back to the sea. Vertebrates first appeared in the sea, and one of its major groups, the tetrapods, probably emerged on land about 360 million years ago at the end of the Devonian. However, some of the tetrapods have reversed this evolutionary journey and returned to the marine realm. Sea turtles, penguins, and whales are examples of extinct groups that took this path. The fossil record contains many more secondary marine creatures. Mesosaurs, long-snouted reptiles with paddle-like feet, inhabited a shallow sea that partially covered the conjoined continents of Africa and South America during the early Permian. The Triassic. There emerged two more successful groups of marine reptiles, ichthyosaurs and sauropterygians, which both survived in the Cretaceous. Typical ichthyosaurs were streamlined animals that must have been excellent swimmers. Sauropterygians were extremely diverse, but notably include the plesiosaurids that have extremely long necks. Like other tetrapods that invaded marine environments, these groups obviously found ecological opportunities that did not exist on land. I've seen a couple like IMAX movies of those guys running around doing crazy stuff. Evolution of amniotic egg. Crocodiles and their remote relatives. Pterosaurs. Dusungirepturiae. Pterodactyl. Pterodactyloids. Distribution of dinosaurs. Origin of feathers. That's cool, a four-winged bird, huh? Feathered dinosaurs. Birds. How much do you know about dinosaurs? Dinosaur eggs and footprints. The first dragon in China. Mass extinction of non-avian dinosaurs. At the end of the late Cretaceous, non-avian dinosaurs completely died out. Although the exact reason of this event remains unknown, several hypotheses have been proposed. 10-kilometer diameter asteroid impacted the Earth, tons of dust lifted in the atmosphere, blocking sunlight, dropping the temperature, food chain disrupted, and dinosaurs die. Sustained volcanic eruptions indicated some continent, polluted environment. Dinosaur eggs could not be hatched for intake of the contaminated food by their moms. Newly evolved angiosperms produce poison and poisonous herbivorous dinosaurs. Mammals arising in the Mesozoic ate up dinosaur eggs. A global climate became more seasonal in the Cretaceous. Dinosaurs could not adapt to the greater temperature fluctuation between day and night and the shrunken, warm, humid climatic region. Back to the Junggar Basin. Since 2000, the Sino-US Xinjiang expedition led by Xu Xing and James Clark has carried out a 10-year fieldwork in the Wukaiwan area of Junggar Basin and discovered the Shishugo fauna, which include basal ceratopsian, Yinlong Downsy, basal stegosaur, Jang Junosaurus, Jungarensis, basal tyrannosaurid, Guanlong Wukai, and beaked herbivorous theropod Limusaurus inextricabilis. This important fauna provided crucial information for the early evolution of many dinosaur groups. Ostrich-like theropod Ornithomimus asiaticus. Finding the place where dinosaurs took off. The discovery of Sinosauropteryx in Sihetan, western Liaoning. 1996 is a milestone in the history of Chinese dinosaur research. For the first time, scientists realized that some dinosaurs had primary feathers. In the following years, other feathered dinosaur findings here, such as Tyrannosauroid delong and Theracinosauroid Bipiaosaurus, Oviraptorosaurid, Caudipteryx, and Proarchaeopteryx. Troodontid, Ginfangoteryx, Dromaeosaurids, Sinomythosaurus, and Microraptor convincingly supported the Dinosaurian origin of bird theory and provided important information for the origin and early evolution of feather and bird flight. Primitive hadrosaur from Inner Mongolia. That's what he looked like with skin, I guess. Parrot-beaked dinosaur from Shandong. Yeah, look at that. It's got a parrot head. Dinosaur hunting in the wilderness. Theoretically, dinosaur fossils are distributed in every corner of the earth, but the unfrequented wilderness with exposed strata is an ideal site to search for their fossils, since they're exposed by weathering of the outcrops. Great China-Canada Dinosaur Project. In the 1980s, Chinese dinosaur researchers Dong Shiming and Zhou Shijin and Canadian paleontologists Philip Curie and Dale Russell led a 5-year Sino-Canadian dinosaur project. Scientists recovered the famous Monolophosaurus jiangyi, a complete theropod, Sinoraptor dongyi, and Mamenchisaurus sinocanidorum, the largest sauropod in Asia in the Junggar Basin, Theracinosaur, Axosaurus, Stegosaur, and Wuerhosaurus in the Ortis Basin, and numerous Protoceratops, Pinacosaurus juveniles in a nest in Bayan Mandahua, Inner Mongolia. They also cleared Oviraptorosaurus from being accused of stealing eggs. first dinosaur, which was excavated, studied, and reconstructed by Chinese scientists, the Lufenogosaurus huanai. Excavations in Liang, Shandong Province in 1950. Shandong University discovered dinosaur and dinosaur egg fossils in the Jing'ankou, Jiaotuan areas in the south suburb of Lianyang City. After that, Yang Zhonglian, Liu Dongsheng, and Wang Kunyi from IVP conducted excavations in the Jing'ankou area. The dinosaur fossils recovered from Liang include the famous Tsintausaurus, Spinorhinus, Tanius sinensis, Pinacosaurus, Grangeri, and complete Psittacosaurus. The study of dinosaur eggs from Liang laid the foundation for the classification and nomenclature systems of dinosaur eggs. The longest necked dinosaur in the world. First dragon in China. In the late 1930s, the founder of Chinese vertebrate paleontology, Yang Zhongjian, and geologist Bian Minian discovered a complete dinosaur skeleton in the early Jurassic strata in Lufeng County, northern Yunnan province. The specimen was named Lufengosaurus huanai by Professor Yang Zhongjian, 1941. Then the specimen was reconstructed under Yang's guidance and installed to display to the public same year, Chongqing. It was the first dinosaur skeleton installed and one of the earliest dinosaurs discovered in China, thus sometimes called the first dragon of China. The Lufeng-Saurischian fauna yielding Lufengosaurus made the Lufeng Basin a classic locality of early dinosaurs and mammals in the world. Dinosaur Cemetery in Sichuan Province. Dinosaur fossils from the Sichuan Basin were first discovered by American geologist George Lauterbach from 1931 to 5. In the following 20 years, the discovery of Omiosaurus jungiensis and Mamenchisaurus constructus made the dinosaurs from Sichuan well known worldwide. In 1977, Shunosaurus Li was recovered from the Dashampu area of Jigang. Dong Shiming led the excavations in this area. The Dashampu fauna includes the sauropods Shunosaurus Li and Omiosaurus tianfuensis theropod, Gasosaurus constructus, basal ornaschizian, Agalosaurus multitudins, Stegosaur, Huayangosaurus, Taibai, etc., which bridged a gap in the dinosaur fossil record in the Middle Jurassic. Dinosaur footprint localities in China. A footprint is a fossil. Any evidence of former life is really a fossil. Here's how it forms, and here's how they make the mold. They can divide them into two types, mold and cast. Dinosaur egg. Dinosaur egg locations in China. Dinosaur eggs and footprints. Criteria for classification of dinosaur eggs. Egg classifications based mainly on the macrostructure of the egg and eggshell, such as egg shape and size, thickness, outer surface ornamentation, nest shape and size on the egg arrangement, and microstructure of eggshell, such as the eggshell unit shape, size arrangement, as well as pore shape, size arrangement, etc. Laying eggs is the reproduction mode of all dinosaurs. Dinosaur egg plays an important role in understanding dinosaur reproductive physiology and breeding behavior. The shape and size of dinosaur eggs vary greatly, as in modern birds and crocodiles. A dinosaur egg was a hard calcareous shell composed of calcite crystallites that are arranged in different architectures. The shape and structure of dinosaur eggs has no direct relation with dinosaur skeletons, except in special occasions. For example, an egg contains embryo skeleton. It is hard to know which kind of dinosaur laid which kind of eggs, so the classification of dinosaur eggs is independently established and different from the classification of organisms. Classification of dinosaur egg is based mainly on the macrostructure of egg and eggshell and macrostructure of eggshell. Chinese dinosaur eggs with more than 60 egg species rank first in the world in both species number and individual quantity, and are unearthed mainly from the late Cretaceous strata. A cut open dinosaur egg with calcite filling. The largest dinosaur egg in the world. It's big. It's a big old one. Macroelongatulithidae includes largest dinosaur eggs in the world. Complete dinosaur eggs and clutches have been found in Tiantai Basin, Zhejiang Province, and the Xixia Basin, Henan Province of China, and Shinangun, Jiangxi Province, South Korea. How much you know about them dinos? What do you know? You don't know nothing. British naturalist Richard Owen. Where did the term come from? Taxon Dinosaura was formerly named 1842, so Richard Owen used it to refer to a distinct tribe of suborder of saurian reptiles that was then being recognized in England and around the world. The terms derived from Greek words dinios, meaning terrible and potent or fearfully great, and sauros, meaning lizard or reptile. Dinosauria is translated into something in Japanese, then the Japanese word is translated as something in Chinese. Interesting. It's the same first symbol here, but this one's different. What are the world records in dinosaurs? The largest dinosaur, Argentinosaurus, smallest Anchiornis, fiercest Tyrannosaurus, and Carcharodontosaurus, fastest Ornithomimus, and Struthiomimus. Must have looked like an ostrich. Struthio. Smartest Troodon, Troodon. Earliest dinosaur Eoraptor, Eocursor, Herrerasaurus. Last Triceratops, Tyrannosaurus, etc. How do you measure the length and weight from tail to tip and shoulder height, maybe? Did dinosaurs exhibit parental care? The oviraptor recovered from Mongolia, squatting on its nest of eggs, and the Maiasaura juveniles in a nest found in the U.S. say they probably did. For several species at least. Can we clone them? We can't with modern technology because dinosaur DNA has been completely degraded during the large geologic time. Even if the DNA were preserved very well, how to make them form chromosomes and express in a cell is also a big problem. Although some people argue that modern bird or crocodile DNA could be transformed into dinosaurs' DNA state, no one knows how to do it at present. Dino DNA. And bingo, dino DNA. Feathered dino. Birds. Bird. Bird is a bird. Bird, successful flying vertebrates. I'm going to start a new video here. There's a snake species too that survives in the high area there by going into hot springs to catch fish. It's pretty neat. It's the highest living snake. Holocene fishes include two groups, Heliocomorphi, bowfins and their fossil relatives as old as the dinosaurs, and Ginglimodi, gars and their fossil relatives. Most common bony fishes today, for example, carps and perches, are teleosts. I've been reading the fossils fine print that is. They have some new finds here. This one's from 2008. Silurian osteoichthyons, extremely rare, often scattered. Guiyu, so far, world's oldest articulated fossil osteoichthyon. Yunnan province, huh? A coelacanth fish from Africa and a living fossil. Latimeria is a recent coelacanth with paired lobe fins. It shows a character transition from fish to four-limbed vertebrates, and thus sometimes it is also called a four-legged fish. The genus Latimeria now includes 2 species. L. calumni, West Indian Ocean coelacanth. So here's a cladogram of their relationship. Phylogenetic tree of the rayfin fishes. Giant fish killers cruising Triassic. Neopterygians including primitive Neopterygians, Holocene, and Telestine fishes. Primitive Neopterygian and the earliest flying fish. Potaichthyes. Sipanceriform sturgeons and their relatives. I saw the giant Chinese sturgeon 2 days ago at the aquarium. That and the beluga whales were the highlight. Triassic ichthyosaur-like fishes. Extinct primitive rayfin fishes. Watch my video of the belugas singing. The most primitive living rayfin fish. Looks like an arowana or something. Lobefin fish. Schizotheracine fishes, snow carps, became adapted to the changing habitats caused by rising of the plateau. The higher elevation, the fewer carp scales, barbels, and pharyngeal teeth rose. Talking about the rise of the Tibetan plateau as the Indian subcontinent crashes into Asia. I'm at the Paleozoological Museum of China, or the Paleontological Museum. My first video we went through the history of humans. They have a smaller gallery that deals with Peking man, and it goes all the way back to Australopithecus. Talks about some of the morphology similarities between proto-Homo species. So we were talking about our fish ancestors here, and we just went through the rayfin fish and cartilaginous fishes. So now we're going to do actinopterygians, the most diversified group of fish. Bony fish, osteoichthyes, are divided into 2 major groups: ray-finned actinopterygians and lobe-finned sarcopterygians fishes. The ray-finned fish have fins consisting of flexible fin rays. Lobe-finned fish, fleshy fins or limbs, well supplied with muscles. The ray-finned fishes include the Cladistia, Chondrostae, Neopterygiae, including the Teleostae and their fossil relatives. They span from late Silurian to present, being the most diversified vertebrate group today with about 29,000 living species, forming the sister group with Actinopterygi. It differs from other fishes in fleshy lobe-paired fins. The monobasal articulation of the paired fins evolved into 4 limbs inland vertebrates. The sarcopterygians first appeared in the late Silurian and were diversified during the Devonian, when they became more abundant and varied than the actinopterygians. Most of them became extinct during the mass extinction event at the end of the Devonian period. Living sarcopterygians include three groups: coelacanth, lungfishes, and tetrapods, to which we belong. Nowadays, most scientists agree that the tetrapods are more closely related to lungfishes than to coelacanths. A Devonian 8-digit tetrapod. Euporosteus unionensis, one of the oldest coelacanths. Saurolepsis, one of the most primitive sarcopterygians. Youngolepsis was the first Chinese fossil fish to be well studied with continuous sectioning method. Professor Minan Chang from the Chinese Academy of Sciences discovered that this fish had no internal nares, ruling out its close affinity with tetrapods. Let's see, tetrapodomorpha include finned tetrapodomorphs and four-limbed tetrapods. L. Manadaensis, the Indonesian coelacanth. This specimen, 1.65 meters in length, 65 kilograms in weight, caught April 5th, 1976, given to the IVPP as a gift from the Comoronian government, March in 1981. The discovery of the Latimeria in December 1938 was one of the most dramatic scientific events in the 20th century. Shortly after the first Latimeria was brought out of the water, scientists found that it was almost identical to the fossil coelacanths, whose ancestors lived 400 million years ago, making it a classic example of the living fossil. Two species of Latimeria both live in deep water along coastlines, one in the West Indian Ocean and the other off Indonesia. Hunting for fishes and squids, it has been reported that they can slow their metabolic rate to reduce their food requirement. They have a lifespan of 100 years, up to 100 years, at both individual and phylogenetic level. Latimeria is truly long-lived, so long live Latimeria. They might have had one of these when I was in Bangkok at the Chulalongkorn Museum. They have a natural museum, natural history model of Latimeria embryo showing oviparous mode of reproduction. Egg-laying. Sarcopterygians are fish ancestor. Sarcopterygi, lobe-finned fish, and tetrapods is a group of osteichthyes.